So suppose I have this CH4 reacting with O2, and it's going on to make CO2 plus H2O. All right, so they are all going to be in the gas phase in this particular case, and you will be given in a complete reaction where you actually have to balance it. So when you look at the number of carbons, they may not be the same, and the oxygens, they may not be the same on both sides. Now, two things you always want to keep in mind when you're balancing equations. The first thing is always balance the atom that has the highest subscript. All right, so that usually works pretty pretty well most of the times. Okay, and then the second thing you want to look for is balance the atom that's by itself at the very end. All right, so in this particular case, the first thing we said, balance an atom that has the highest subscript, which is going to be 4, which is going to be the hydrogen here. And then balance, when we're looking at the hydrogens, how many hydrogens you have on the reactant side? We have 4 hydrogens. And how many hydrogens you have on the product side? We have, well, we have only H2O. That means there's only 2 hydrogens. So what would you do to balance the hydrogens there? Well, I can go ahead and put 2 there. Okay, so when you do that, the hydrogens are balanced. Now let's focus on the carbons. How many carbons you have on the reactant side? I got 1 carbon here. Okay, and I got 1 carbon on the product side. So your carbons are already balanced, so you don't have to worry about balancing the carbons. Okay, and remember, I said leave the element that's by itself, whether it's on the reactant side or on the product side, until the end to balance it. So the oxygen, we have it by itself, so that's why I didn't really balance it until I have every other element balanced. Okay, so now when it comes down to balancing this oxygen, now let's go on to the product and figure out how many oxygens you got here. So I have 2 oxygens here on the CO2, and on the water, how many oxygens I got? Well, I have 2 oxygens as well. So that's a total of 4 oxygen atoms here. So that means you got to make sure you have 4 oxygen atoms on the reactant side, and that's we can do that by just putting 2 in front of the O2. So that's going to be a complete balanced equation for you. Okay, let's take another example that's going to be maybe a little bit complicated. Suppose I have C8 H18, that's the active ingredient in gasoline, that's octane. When it's burned in the presence of an oxygen, it obviously makes carbon dioxide and water. Okay, now let's try to balance this equation. So we're still going to be using the same drill, okay? Focus on the atom that has the highest subscript, okay? So the highest subscript you got in both of those sides is going to be the hydrogen. So hydrogen has 18, and then you have carbon, all right? So those are the 2 elements I have here that has the highest subscript. So worry about balancing the hydrogen first, okay? So since I have 18 hydrogen on the reactant side, I need to have 18 hydrogens on the product side. So what would I have to put in front of the water to make 18 hydrogens? Well, you already have 2 hydrogens in water, so if I put 9 in front of H2O, that will take care of the number of hydrogens there. Okay, so that's the hydrogens now. Let's focus on your carbons. I have 8 carbons on your reactant side. And how many carbons you have on the product side? Well, so far we have only 1 carbon on the product side. And to make a total of 8 carbons on the product side, I can go ahead and put 8 in front of CO2. And that takes care of the number of carbons there. So now you have your carbons and your hydrogens balanced on both sides. And like I said, we will worry about the oxygens at the end because oxygen was by itself. Now, focus on how many oxygens you got on the product side. So I have 8 CO2, that gives you 16 oxygen. Okay. So maybe I can change the color there. So 8 CO2 gives you 16 oxygen here. And then plus how many oxygens you have on the water. I got 9 water molecules, so that's going to be 9 oxygens there. So that's a total of 25 oxygen atoms there. Okay, so since you have 25 oxygen atoms, I need to go back and make sure I have 25 oxygens on the reactant side. And since you already have 2 here, what number would you put in front of the coefficient as a coefficient to make a total of 25 oxygens? Well, the answer is going to be 12 and a half. So go ahead and put 12 and a half momentarily there. Okay, now one thing you want to keep in mind that you don't want to have any decimals or fractions as in a coefficient. Okay, but it's okay to put 12 and a half momentarily, and then we can worry about changing it quickly. So once you go ahead and put 12 and a half, now you need to worry about changing into a whole number. So think of a smallest integer that you can multiply 12 and a half with so that you get a whole number. Well, since it's in half of the number, you can multiply this by 2. So to be consistent, you have to multiply this whole reaction by 2. Okay, so when you multiply this whole reaction, it will balance out by itself. So I got, then I would have, let me just copy this down here. Okay, so I can clearly see how I got, when I multiply everything by 2, I would have 2C8H18, and then this 12.5 is going to change to 25, and then this 8 is going to change to 16, and then this 9 is going to change to 18. So that's going to be your final balanced equation where there's no fractions and no decimals as in coefficients. Everything is in a whole number. Okay, let's try one more. Assume I have Na3PO4 aqueous reacting with COCl2 aqueous, and it goes on to make CO3 PO4 2 solid and NaCl aqueous. Okay, so let's worry about balancing this equation, and let's see. We don't really have any element by itself, so let's focus on the atoms that has the biggest subscript. So one of the atoms I can see that has the biggest subscript in there is obviously going to be the oxygen here. All right, so how many oxygens we got here? And the PO4, you have 2 outside, so that gives you 8 total oxygen atoms there. Okay, and you got to make sure you balance the oxygens. But in addition to that, hold on to worry about the other big subscripts as well. The other big subscript you got here is the cobalt. That gives you 3 cobalts here, and we can worry about balancing that as well. Now let's go back and focus on the oxygen first. So you got 8 oxygens on the product side, and now when I go back onto the reactant side, how many oxygens I have? The only source for the oxygen is the sodium phosphate, or the first reactant, which actually gives you 4 oxygen atoms. So to make 8 oxygen atoms, what would I have to do? I would go ahead and multiply this reactant by 2. So put 2 as a coefficient in front of sodium phosphate. Okay, now let's worry about balancing the cobalts. Okay, so when you're balancing the cobalt, you have 3 cobalts in there. And when I'm looking at my reactant, the cobalt source is going to be COCl2, and there is only 1 cobalt so far. So since there's only 1 cobalt, I can go ahead and put 3 in front of cobalt chloride, and that will take care of the cobalts. Then finally, let's look at other atoms now. Let's look at the sodiums. Okay, so on the reactant side, how many sodiums I have? Well, I got Na3, but there's 2 in front of it, so that's going to be 6 sodium atoms. And when I'm looking at my product, the only source for sodium is going to be this NaCl, and right now it's got only 1 Na. So to make 6 of those, I would have to go ahead and put 6 in front of NaCl, and that takes care of the sodiums. Now let's worry about the chlorine as well. You got to make sure you check every single element for their balancing. The chlorine here, I have COCl2, but there's 3 in front of it, so that's going to be 6 chlorine atoms there. And when you have 6 chlorine atoms on the product side, there is 6 in front of NaCl, so that makes it 6 chlorine atoms as well. All right, so that's your balanced equation. Everything is balanced in this case. All right, so hopefully this video was helpful. If you have any questions, feel free to leave any comments in the section below.